Alright, this is lesson 8.3, chapter 8, lesson 3 on functions and equations. So far up to this point, you have learned what functions are and you've put them into function tables. Today, you're going to be taking functions and writing equations for them. So before we start, a little bit of vocabulary setup. First off, we're going to fill this graphic organizer in because it might help you understand one of our vocabulary words. So our vocabulary word here is going to be a linear function. Is a function whose graph is a line. Alright, sounds complicated, but let's go through this to help you remember it. First off, linear, if something is linear, it means it's in a straight line. So that's the definition of linear. Now, the everyday definition of function, I'm not talking about math. So if you think of the function of a stapler, its function is to staple papers. So definition of a function is how something works, or its purpose. Now, we'll go straight down to the math definition of a function. And the math definition of a function is basically how an input value is related to an output value, or how two variables are related. So, how two different variables are related. Remember, if the function rule is plus 2, if the x variable is 2, you would add 2 to get the y, which is 4. So the function rule tells you how they're related. And last, what do you notice about this graph? You should notice, hopefully, that it is in a straight line, which makes it linear. So all you have to do is say it is a straight line. So, just so you know, linear functions are just functions that when you graph them, they make a straight line. So that's really all they are. Sounds more complicated than they are. So on the next page, here is what we're going to be doing. We are going to be kind of taking what we did yesterday, where we would put a function into a function table. And then on the next page, we're going to be taking this function table to graph it, which is much, much easier than you're probably thinking. So in example 1, it says write an equation to represent the function shown in the table. So I'm going to give you a couple steps for this. First off, in an equation, when you're writing them from a function table, you are always going to start, see how it's x and y? You are always going to start with the y equals. Now remember, equations have equal signs. So your equation will always start with y equals in these functions. Now you just have to figure out what comes after the equal sign, and you've already actually done this. So take a look at our input-output table. The number 1, 2, 3, 4, 5. To get the output, you multiply by 9. To get 9, 18, 27, 36, 45. Now that means our rule, remember, if the input is x, you would do 9 times x to get your output. So these symbols here is what comes after it. So the value of y over here is 9 times x. So remember, you always start with y equals, and then you figure out your function rule, and that's the second part of your equation. That's all you do. So I'm going to get you started in problem A. It says write an equation to represent the function shown in the table. So I'll tell you what to do. Start it with y equals. Figure out the rule going from the x to the y, and that rule as symbols will be the second part of your equation. So if you think you can get it, pause it, do it, and check. Restart the video and check. If you're not sure, you can kind of stay on the video and do it with me. Alright, now let me start here. First, to do this, I'm going to add another column and just put x, because that's going to help me with my equation. Now remember, when I have to write an equation, start with y equals. Now to get the rest of my equation, I'm going to figure out my rule. So when I'm going from 1 to 16, 2 to 32, I notice that 1 times 16 is 16, 2 times 16 is 32. So I'm actually going to write that down. 1 times 16, 2 times 16, 3 times 16 is 48, and I can continue that with 4 times 16 and 5 times 16. So here I would write x times 16. Now, that is going to be the second part of my equation, x times 16, but don't write it looking like that. Remember, to write that, you would write 16x. That's how you write x times 16. So remember where these two parts came from. You start with y equals, and whatever the function rule is what comes after the equal sign. All right, now, let's continue down below. This is where we're going to be graphing these functions. It says, you could also graph a function. If the graph is a line, the function is then called a linear equation. When graphing the function, the input is the x and the output is the y. So remember, the input x is your first coordinate, the output y is your second coordinate. So going on to the next page, they are going to, on this page, give you the function equation. Instead of you having to find it, graph y equals 2x. Now, to graph that, let me show you what you would do. First thing is, you would just come up, remember, with your independent variable, you can make it whatever you want. So your best bet for the easiest work is to make it 0, 1, and 2. Now remember, the rule is 2 times x. So here we have 2 times x. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. So this is just a function table like we did. Now look at the coordinates. If you take the x and the y, you get the coordinates. So 1, 2 is 1, 2. 2, 4 is 2, 4. So step 2, you just make a graph and graph these coordinates. So 0, 0 is right here. 1, 2 is right here. And 2, 4 is right here. So you're taking your equation, putting it in a function table, and graphing it. Now in B, we will do that one together. So then I'm going to have you try C. So in B, the equation is y equals x plus 1. Now I'm going to move over here so we have a little more room. So we have y equals x plus 1. Now, first thing I'm going to do is make a little table right here. So this is going to be my y values, this is going to be my function, and this is going to be the one column on the right will be the column on the left will be my x values. This will be my function, and this will be my y values. So I'm going to start with 0, 1, and 2. Now I'm going to put those numbers through x plus 1 as my rule. So 0 plus 1 will get me 1. 1 plus 1 will get me 2. And 2 plus 1 will get me 3. So now I have my x values and I have my y values. So I have 0, 1, which I'm going to graph. 0, go over 0, up 1 will be right about there. Then I have 1, 2. So go over 1, up 2 should be right there. Then I have 2, 3. Go over 2, up 3 should be right there. So that is my graph. And it's in a straight line, so it's a linear graph. Alright, now you are going to do problem C. You need to take this equation, make a function table for your x, y values, and then you're going to graph it. So pause the video, try C, and give it a start. If you're not sure, you can kind of just do it with me on the video. Okay, so let's start this out. I'm going to take this and I'm going to make, too thick. I'm going to make my function table. So for my function table, make this one a little neater. I'll have my x value, my rule, which is 3x plus 2, and then my y value. Alright, now let me blow this up so we can see it a little better. Now for your x value, remember, you can choose anything, but if you want to make your life easier, you you choose 0, 1, and 2. Now I'm going to put 0, 1, and 2 into my function rule. So 3 times 0 plus 2. So 3 times 0 is 0, plus 2 is 2. So now I'm going to do the 1. 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5. Now I'm going to do it for the 2. 3 times 2 plus 2. 3 times 2 is 6, plus 2 is 8. So here are my x values. Here are my y values. You can write them as ordered pairs if you want. You could write 0, 2, 1, 5, and 2, 8. You don't need to, though. All right, now we're going to go over and we're going to graph those coordinates. So let me get my pen ready. All right, so we're going to start with 0, 2. So you go over 0, up 2. It should be right there. 1, 5, go over 1, up 5. And then 2, 8, you'd go over 2 and up 8, which would be way off the graph somewhere up there. But if you notice, it is a nice straight line going right through here up to there. All right, so that's all you do. Now, we're going to go down to these examples. And this is where we're going to kind of do the reverse. We're going to take the graph, go to a function table, and then get the equation. So it's the reverse of what we just did. So this says, Martino constructed the graph shown, which shows the height of his cactus after several months. So he has input 1, output y. And if you look over here, 142 matches this. So for 1 year, his cactus grew 42 inches. 2 years, it was 44 inches. In 3 years, it was 46 inches. Okay, now when it says make a function table, that's kind of what you did. Each year, it gives you how many inches it was. Now for 4, it says write an equation from that graph that could be used to find the height x of the cactus after height y after x years. So watch how this works. Remember, when you write your equation, you want to start with, let me get this down here a little bit. You want to start with y equals. So every one of these equations is going to start with y equals. Now, here's what you got to see what we're doing here. Now, when I'm looking at this, I'm like, all right, 1 plus 41 is 42, but 2 plus 41 is 44. 1 times 42 is 42. 2 times 42 is not 44. So this is going to be one of those more complicated function rules. So watch as I'm going down here. I'm going 42, 44, 46. They are skip counting by 2. So that's going to give me my first part, which is 2x. But now, to get the next part, I'm going to have to do some addition or subtraction. So let me make this a little bigger. Make my pen a little smaller. Now, I'm going to start with the 2x part. So 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. And the question is, how do I go from these numbers the rest of the way to the y? And if you look, you'll see 2 plus 40, that's supposed to be a 40, is 42. 4 plus 40 is 44. And 6 plus 40 is 46. So the rest of my function rule should be 2x plus 40. So, in order to get your equation from a situation, you need to start at the graph, fill out your function table, and then get your equation. All right, so now, here's where you're going to try it. You are going to read problem D. Now, you kind of have to do this in the right order. So I'll kind of tell you what you're going to do, but not tell you completely. So after you read it, you are going to go over to your graph, and you have to fill in your x and y values. Now, I'll give you a hint for the very first one. In the first one, if you look at this dot, the coordinates would be over 1, up 20. So you have 1, 20. Now, you're going to do that for the rest of these dots to fill in your table. Once you get your table, you're going to write your equation right here, starting with y equals. So, give it your best shot. Pause it. When you're done, restart it and see if you're right. Go. Okay, let's see how you did. So the question, we'll read it first. The graph shows the total amount y that you spend if you buy one book and X magazines. Make a function table for the input-output values. So that's what you do first. Write an equation from the graph that could be used to find the total amount y if you buy one book and X magazines. Alright, so let's start with the rest of the coordinates. This one here is at 225. So I'm going to write 225. Okay, the next dot right here is at 330. So you should have 330. And then the next dot here is at 435. So that will be 435. So the first part was already done. We filled in the table. But now we need to write our equation from this table. So all your equations are going to start with y equals. Now, trying to figure this out, I'm looking here. I'm like, all right, 1 plus 19 is 20. 2 plus 19 is 21, so it's not addition. 1 times 20 is 20. 2 times 20 is 40, so it's not multiplication. So this is going to be one of those more complicated ones. So remember, you look over here, see what it's counting by going down the column. So it's plus 5, plus 5, plus 5. That means your function is going to start with 5x. Now, I'm going to write those numbers down. So 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20. So how do you go the rest of the way from 5 to 20, 10 to 25, 15 to 30, and 20 to 35? To go the rest of the way, you would do plus 15. 5 plus 15 is 20, and it works for each one. 10 plus 15, 15 plus 15, and 20 plus 15. You can read my writing. So that means the rest of the function is 5x plus 15. If you had this equation, then you made it through and you were correct. All right, you can ask me any other questions that you have. Thanks, guys.